Well, what keeps the planets going around the sun?
How come they stay in orbit?
Oh yeah, how come they stay in orbit?
Okay, so here's a question that we'll start with. Make your prediction. Which one's gonna fall to the ground first?
Well, I would think the lemon would.
Okay,
let's go. It's heavier.
Let's go test your
paper.
Let's go test your hypothesis.
Oh, okay.
All right, so your guess is that the lemon's gonna fall first to the ground.
Yeah.
Okay.
Just so float away.
Okay, ready?
Go.
Go. And there's a paper flying away. So the reason why the paper didn't touch the ground first and the lemon did is because of air resistance.
Because the paper is so light.
Because the paper has more surface area, it's light.
Yeah.
That the air molecules come underneath and stop it and slow it down. It actually made it start flying.
And because that's so much heavier, they can't do that?
And there's no air resistance.
Oh, yeah.
Less, at least. Now, do a thought experiment. Imagine that you dropped this and this in a room with no air in it. All the air was taken out. There was zero air. It was just a room with no air molecules.
Then they'd drop at the same time.
They would fall and touch the ground at the same time.
Yeah.
So it doesn't really matter so much about the
heaviness.
weight. No, it matters because what matters is the air resistance. It was the air resistance that actually made this slower, not the weight.
Yeah.
Not the mass.
So what if you had this and this and dropped it at the same time?
This
is heavier than this.
In air?
Yeah. Would they drop at the same time?
I suspect that they would have different air resistances because this is more smooth
and round,
this is more
round.
rough. So I feel like this would touch the ground first. That's my theory.
Oh yeah.
Yeah. Now, if you were in a room where there was no air, then they would both. If you dropped a feather and this in a room with no air,
yeah,
same. Because
Wow.
everything falls at a constant rate of 9 meters per second squared. So in space, the reason why the Earth is able to just keep orbiting the sun is because there's no air resistance. There's nothing slowing it down. There's no friction. The Earth isn't moving through anything and that's stopping it. It's just nothingness. It's just going through
nothingness. So the planets could never move closer to the sun.
They are slowly
Eventually
moving.
the sun is just going to peter out.
The sun will eventually grow and
years
explode.
Yeah.
So to imagine, this is space-time. This is the sun.
Right.
Non-size conformity. Obviously we have friction. But look, when you put two objects, this is one object. Look, this object is creating this gravity curve.
Yeah, I see it.
So when I put another object,
it's gonna bump right into it because it goes downhill.
Yeah, but in space, the Earth got knocked and it will just keep going like this.
But what makes that like that then?
Because in space, an object in motion remains in motion unless acted on by another
there's no
object.
Air.
Another force. Because there's no air. But right now we have, of course, we also have the Earth's gravity and all these other forces. But this is kind of what it would be like in space. I did my best in trying to explain relativity to my grandma, and I used a 2D visualization like this to explain it to her, but a more accurate depiction of how general relativity works is through this animation. This is definitely better describing of what's going on. It's 3D, it's happening in all dimensions, and it's really fascinating. Einstein was a genius. I hope you enjoyed the video. Peace.